Hi, I am Will,
I'm Ethan.
and our MOX project was about exploring mechanisms for the placement of abortion clinics with agent-based models. This work was inspired by something called the p-median problem, which says, given some set of facilities N and some population distribution, find the optimal set of facilities to minimize the average travel distance between each member of your population and the nearest facility. So we took this frame and we wanted to apply it to the problem of facility placement of abortion clinics, which is not only an interesting issue, but also a socially important one. Before Dobbs, the Supreme Court decision, which made abortion illegal in many states this summer, the average commute time in Texas and Louisiana was about 15 minutes to the nearest clinic. After Dobbs, it's about 6 hours. So we have a situation in which the optimal facility placement has changed radically because facilities are no longer allowed to be placed in a big swath of the country. So we had a couple of research questions. We wanted to explore the microscale mechanisms which were leading to the empirical placement of abortion clinics that we see. We wanted to understand what are the motives behind the clinics? Are they trying to minimize distance? Are clinics coordinating with each other? And are political factors influencing their position? So to tackle these questions, we implemented an agent-based model with various sets of rules. And we tried to determine, based on a couple of different factors, how the agent-based model lined up with empirical data to either reject or accept possible hypotheses to the microscale dynamics of the clinic placement. So the sort of criteria we used were the average objective function score, the patient distance distribution. So this is how far do you have to travel to the nearest clinic as a distribution. And finally, visual similarity between the simulation output and the empirical data. The way our simulation worked is that we had a population of agents. Each agent represents a single clinic. The agents are placed within the bounds of the contiguous US, and we distribute 30,000 citizens according to empirical population data. We assume that each citizen visits the nearest clinic, and we then calculate the objective function for each clinic, which is for the average distance someone has to travel to the nearest clinic times the number of people that clinic serves. The dynamics of our model involved every time we choose some number of clinic locations, and we then, for each clinic location, have them generate a new test position. And then we reevaluate the objective function. If the objective function is higher, they accept the new location. And if it's not, they stay in the same location. And this may sound a little bit outlandish, but it is inspired by real world events that abortion clinics after Dobbs moved out of states like Mississippi to New Mexico. So clinics can move across the country. That reflects the reality well. We tried several different sets of rules. The first rule was coordinated decision making. So here, each agent, every time step, a single agent is chosen, and that agent picks a new position and tests it. And if the new position improves the global objective function, so that is the sum of all of the objective functions, then they accept the move. So this is simulating a situation in which all of the abortion clinics are working together to maximize access. So what we see here is we ran the simulation allowing clinics to pick any location and restricting clinic locations only to states where abortion is legal, but we disallowed, we included the populations, the citizens in states where it's legal in our estimates. So they have to compensate for those citizens. We can see there's a pretty radical difference. The simulated data does much, much better. On average, people are much closer to the nearest clinic than they are in the real world. So this tells us that empirical clinic locations are not simply trying to minimize the average distance. The second situation we looked at was each agent moves individually. So every time step, all agents move or pick a new candidate location. And if their individual objective function is increased in the new candidate location, they will choose that location. So here they're all working independently to provide access for themselves in their area. What we see here is similar results as far as the distance distribution goes, at least on the long log plot. But we see that the visual similarity, there's not very much clustering. clinics are evenly spread across the space, which is not realistic, not what we really see in the data. So it seems like individual decision making is not a good strategy for placing your clinics.
Yes, and so in our objective function scores, this becomes even starker, where in the global minimization, the objective function, which again is giving an indication of the average distance that a person might have to travel, the score is nearly half of what we see in the empirical data. So if minimization of distance at a global or just on an individual basis for each facility is not how clinics are deciding their location in the real world, what might explain it? So what we looked at next was the political map. So what this is clinics overlaid on the uh, uh, portion of votes that went to Joe Biden in the 2020 election, just as a proxy way of indicating how blue or red is a given area. Now, we initially looked at this as a way of indicating could political affiliation be a possible explainer? And from this, we do see that blue, at least visually, bluer counties do seem to have more abortion clinics than redder counties, with the white counties being kind of evenly split politically, and you do see some in those areas as well. So this gave us an indication that we should explore this further. So what we do is then we tried to, all right, so we tried a partisan model. And what this does is we do not actually have steps of agents moving around. We just randomly place them, but we place them weighted by the political map. So when choosing a random location for a facility, they are more likely to land in a place that has more where more votes were cast for Joe Biden in the 2020 election, and then we use this to determine the locations. Now, just visually comparing the left and the right, this looks like a more plausible map where we don't have facilities spread out evenly across states, which while that might be better in practice for people in the United States that want abortions. That is not what we saw in the empirical data. What we see here is that weighting by the number of votes cast for Democratic presidential nominee does seem to better match. So we then dove further into how the other metrics that we're looking at compare to the empirical data. And what we can see here is that the political initiated map actually has a much heavier tail. So that's good. And it seems like it actually has a heavier tail than the empirical data, though there might be some kind of edge case reasons for this. So you can note that there are some clinics in more central Montana, I believe there, and we don't really have those in our simulation. So that could just be because there is such a gap between facilities in that part of the country, could placing a facility there kind of get the distribution to be similarly leveled of a heavy tail as the empirical data. So those are things that we will be looking at in kind of future work, both sensitivity analysis to these approaches, and then if partisan lean of an area is a good explanation for why an abortion clinic may be present or not present, we should examine what the kind of order of events there. Are facilities being attracted to bluer areas, or are they being repelled or kind of cast out of redder areas? And so for this, if we have empirical data that evolves over time and empirical data post the Dobbs decision, that can help possibly tease out whether that is a reason, whether either of those are reasonable mechanisms that are causing the behavior here. The other thing that can be looked at further is for post Dobbs, if facilities are deciding whether to close down or move out of states that where abortion is no longer legal, are there optimal strategies for where they can move that would best benefit people that are in states where abortion is no longer legal, and what are the mathematics of what portion of those facilities would need to move in order to most effectively reduce the distance that would need to be traveled by people living in those states that no longer allow abortions. Thank you.